Inkjet printers are the most commonly used type of printer, and range from small inexpensive consumer models to expensive professional machines. The concept of inkjet printing originated in the 20th century, and the technology was first extensively developed in the early 1950s. Starting in the late 1970s, inkjet printers that could reproduce digital images generated by computers were developed, mainly by Epson, Hewlett-Packard, and Canon. In the worldwide consumer market, four manufacturers account for the majority of inkjet printer sales: Canon, HP, Epson, and Lexmark, a 1991 spin-off from IBM. The emerging inkjet material deposition market also uses inkjet technologies, typically printheads using piezoelectric crystals, to deposit materials directly on substrates. There are two main technologies in use in contemporary inkjet printers: continuous and drop-on-demand. Continuous inkjet. The continuous inkjet method is used commercially for marking and coding of products and packages. In 1867, Lord Kelvin patented the siphon recorder, which recorded telegraph signals as a continuous trace on paper using an inkjet nozzle deflected by a magnetic coil. The first commercial devices were introduced in 1951 by Siemens. In CIJ technology, a high-pressure pump directs liquid ink from a reservoir through a gun body and a microscopic nozzle, creating a continuous stream of ink droplets via the plateau-Rayleigh instability. A piezoelectric crystal creates an acoustic wave as it vibrates within the gun body and causes the stream of liquid to break into droplets at regular intervals. 64,000 to 165,000 droplets per second may be achieved. The ink droplets are subjected to an electrostatic field created by a charging electrode as they form. The field varies according to the degree of drop deflection desired. This results in a controlled, variable electrostatic charge on each droplet. Charged droplets are separated by one or more uncharged guard droplets, to minimize electrostatic repulsion between neighboring droplets. The charged droplets pass through another electrostatic field and are directed by electrostatic deflection plates to print on the receptor material, or allowed to continue on undeflected to a collection gutter for reuse. The more highly charged droplets are deflected to a greater degree. Only a small fraction of the droplets is used to print, the majority being recycled. CIJ is one of the oldest inkjet technologies in use and is fairly mature. The major advantages are the very high velocity of the ink droplets, which allows for a relatively long distance between print head and substrate, and the very high drop ejection frequency, allowing for very high-speed printing. Another advantage is freedom from nozzle clogging, as the jet is always in use, therefore allowing volatile solvents such as ketones and alcohols to be employed, giving the ink the ability to bite into the substrate and dry quickly. The ink system requires active solvent regulation to counter solvent evaporation during the time of flight, and from the venting process, whereby air that is drawn into the gutter along with the unused drops is vented from the reservoir. Viscosity is monitored and a solvent is added to counteract solvent loss. Drop-on-demand. Drop-on-demand is divided into thermal DOD and piezoelectric DOD. Thermal DOD. Most consumer inkjet printers, including those from Canon, Hewlett-Packard, and Lexmark, use the thermal inkjet process. The idea of using thermal excitation to move tiny drops of ink was developed independently by two groups at roughly the same time: John Vaught and a team at Hewlett-Packard's Corvallis division, and Canon engineer Ichiro Endo. Initially, in 1977, Endo's team was trying to use the piezoelectric effect to move ink out of the nozzle, but noticed that ink shot out of a syringe when it was accidentally heated with a soldering iron. Vaught's work started in late 1978 with a project to develop fast, low-cost printing. The team at HP found that thin film resistors could produce enough heat to fire an ink droplet. 2 years later, the HP and Canon teams found out about each other's work. In the thermal inkjet process, the print cartridges consist of a series of tiny chambers, each containing a heater, all of which are constructed by photolithography. To eject a droplet from each chamber, a pulse of current is passed through the heating element, causing a rapid vaporization of the ink in the chamber and forming a bubble, which causes a large pressure increase, propelling a droplet of ink onto the paper. The ink's surface tension, as well as the condensation and resultant contraction of the vapor bubble, pulls a further charge of ink into the chamber through a narrow channel attached to an ink reservoir. The inks involved are usually water-based and use either pigments or dyes as the colorant. The inks must have a volatile component to form the vapor bubble, otherwise droplet ejection cannot occur. As no special materials are required, the print head is generally cheaper to produce than in other inkjet technologies. Piezoelectric diode. Most commercial and industrial inkjet printers and some consumer printers use a piezoelectric material in an ink-filled chamber behind each nozzle instead of a heating element. When a voltage is applied, the piezoelectric material changes shape, generating a pressure pulse in the fluid, which forces a droplet of ink from the nozzle. Piezoelectric inkjet allows a wider variety of inks than thermal inkjet, as there is no requirement for a volatile component, and no issue with cogation, but the print heads are more expensive to manufacture due to the use of piezoelectric material. A diode process uses software that directs the heads to apply between 0 to 8 droplets of ink per dot, only where needed. Piezo inkjet technology is often used on production lines to mark products. For instance, the use before date is often applied to products with this technique. In this application, the head is stationary and the product moves past. Requirements of this application are high speed, a long service life, a relatively large gap between the print head and the substrate, and low operating cost. Ink formulations. The basic problem with inkjet inks is the conflicting requirements for a coloring agent that will stay on the surface versus rapid disbursement of the carrier fluid. Desktop inkjet printers, as used in offices or at home, tend to use aqueous inks based on a mixture of water, glycol and dyes or pigments. These inks are inexpensive to manufacture, but are difficult to control on the surface of media, often requiring specially coated media. HP inks contain sulfonated polyazo black dye, nitrates and other compounds. Aqueous inks are mainly used in printers with thermal inkjet heads, as these heads require water to perform, while aqueous inks often provide the broadest color gamut and most vivid color. Most are not waterproof without specialized coating or lamination after printing. Most dye-based inks, while usually the least expensive, are subject to rapid fading when exposed to light or ozone. Pigment-based aqueous inks are typically more costly but provide much better long-term durability and ultraviolet resistance. Inks marketed as archival quality are usually pigment-based. Some professional wide-format printers use aqueous inks, but the majority in professional use today employ a much wider range of inks, most of which require piezo inkjet heads and extensive maintenance. Solvent inks. The main ingredient of these inks are volatile organic compounds, organic chemical compounds that have high vapor pressures. Color is achieved with pigments rather than dyes for excellent fade resistance. The chief advantage of solvent inks is that they are comparatively inexpensive and enable printing on flexible, uncoated vinyl substrates, which are used to produce vehicle graphics, billboards, banners and adhesive decals. Disadvantages include the vapor produced by the solvent and the need to dispose of used solvent. Unlike most aqueous inks, prints made using solvent-based inks are generally waterproof and ultraviolet resistant without special overcoatings. The high print speed of many solvent printers demands special drying equipment, usually a combination of heaters and blowers. The substrate is usually heated immediately before and after the print heads apply ink. Solvent inks are divided into two subcategories: Hard solvent ink offers the greatest durability without specialized overcoatings but requires specialized ventilation of the printing area to avoid exposure to hazardous fumes. While mild or eco-solvent inks, while still not as safe as aqueous inks, are intended for use in enclosed spaces without specialized ventilation of the printing area. Mild solvent inks have rapidly gained popularity in recent years as their color quality and durability have increased while ink cost has dropped significantly. UV curable inks. These inks consist mainly of acrylic monomers with an initiator package. After printing, the ink is cured by exposure to strong UV light. Ink is exposed to UV radiation where a chemical reaction takes place where the photoinitiators cause the ink components to cross-link into a solid. Typically a shutted mercury vapor lamp or UV LED is used for the curing process. Curing processes with high power for short periods of times allow curing inks on thermally sensitive substrates. UV inks do not evaporate but rather cure or set as a result from this chemical reaction. No material is evaporated or removed, which means about 100% of the delivered volume is used to provide coloration. This reaction happens very quickly, which leads to instant drying that results in a completely cured graphic in a matter of seconds. This also allows for a very fast print process. As a result of this instant chemical reaction, no solvents penetrate the substrate once it comes off the printer, which allows for high-quality prints. The advantage of UV curable inks is that they dry. As soon as they are cured, they can be applied to a wide range of uncoated substrates, and they produce a very robust image. Disadvantages are that they are expensive, require expensive curing modules in the printer, and the cured ink has a significant volume and so gives a slight relief on the surface. Though improvements are being made in the technology, UV curable inks, because of their volume, are somewhat susceptible to cracking if applied to a flexible substrate. As such, they are often used in large, flatbed printers, which print directly to rigid substrates such as plastic, wood or aluminium where flexibility is not a concern. Dye sublimation inks. These inks contain special sublimation dyes and are used to print directly or indirectly onto fabrics which consist of a high percentage of polyester fibers. A heating step causes the dyes to sublimate into the fibers and create an image with strong color and good durability. Head design. There are two main design philosophies in inkjet head design: fixed head and disposable head. Each has its own strengths and weaknesses. Fixed head. The fixed head philosophy provides an inbuilt print head that is designed to last for the life of the printer. The idea is that, because the head need not be replaced every time the ink runs out, consumable costs can be made lower and the head itself can be more precise than a cheap disposable one, typically requiring no calibration. On the other hand, if a fixed head is damaged, obtaining a replacement head can become expensive, if removing and replacing the head is even possible. If the printer's head cannot be removed, the printer itself will then need to be replaced. Fixed head designs are available in consumer products, but are more likely to be found on industrial high-end printers and large-format plotters. In the consumer space, fixed head printers are manufactured primarily by Epson and Canon. Hewlett-Packard also offers a few fixed head models, such as the HP OfficeJet Pro X576DW. Industrial fixed head print heads are manufactured by these companies: Kodak, Versamark, Trident, XAAR, Spectra, Hitachi, Ricoh, HP Cytec, Brother, Konica Minolta, Seiko Epson, and Toshiba Tech. Disposable head. The disposable head philosophy uses a print head which is supplied as a part of a replaceable ink cartridge. Every time a cartridge is exhausted, the entire cartridge in print head are replaced with a new one. This adds to the cost of consumables and makes it more difficult to manufacture a high-precision head at a reasonable cost, but also means that a damaged or clogged print head is only a minor problem. The user can simply buy a new cartridge. Hewlett-Packard has traditionally favored the disposable printhead, as did Canon in its early models. This type of construction can also be seen as an effort by printer manufacturers to stem third-party ink cartridge assembly replacements, as these would-be suppliers don't have the ability to manufacture specialized printheads. An intermediate method does exist: a disposable ink tank connected to a disposable head, which is replaced infrequently. Most high-volume Hewlett-Packard inkjet printers use this setup, with the disposable printheads used on lower-volume models. A similar approach is used by Kodak, where the printhead intended for permanent use is nevertheless inexpensive and can be replaced by the user. Canon now uses replaceable printheads which are designed to last the life of the printer, but can be replaced by the user should they become clogged. Cleaning mechanisms. The primary cause of inkjet printing problems is due to ink drying on the printhead's nozzles, causing the pigments and dyes to dry out and form a solid block of hardened mass that plugs the microscopic ink passageways. Most printers attempt to prevent this drying from occurring by covering the printhead nozzles with a rubber cap when the printer is not in use. Abrupt power losses, or unplugging the printer before it has capped the printhead, can cause the printhead to be left in an uncapped state. Even when the head is capped, this seal is not perfect, and over a period of several weeks the moisture can still seep out, causing the ink to dry and harden. Once ink begins to collect and harden, the drop volume can be affected, drop trajectory can change, or the nozzle can completely fail to jet ink. To combat this drying, nearly all inkjet printers include a mechanism to reapply moisture to the printhead. Typically there is no separate supply of pure ink-free solvent available to do this job, and so instead the ink itself is used to re-moisten the printhead. The printer attempts to fire all nozzles at once, and as the ink sprays out, some of it wicks across the printhead to the dry channels and partially softens the hardened ink. After spraying, a rubber wiper blade is swept across the printhead to spread the moisture evenly across the printhead, and the jets are again all fired to dislodge any ink clumps blocking the channels. Some printers use a supplemental air suction pump, utilizing the rubber capping station to suck ink through a severely clogged cartridge. The suction pump mechanism is frequently driven by the page feed stepper motor. It is connected to the end of the shaft. The pump only engages when the shaft turns backwards, hence the rollers reversing while head cleaning. Due to the built-in head design, the suction pump is also needed to prime the ink channels inside a new printer, and to reprime the channels between ink tank changes. Professional solvent and UV curable ink wide-format inkjet printers generally include a manual clean mode that allows the operator to manually clean the printheads and capping mechanism and to replace the wiper blades and other parts used in the automated cleaning processes. The volume of ink used in these printers often leads to overspray, and therefore build-up of dried ink in many places that automated processes are not capable of cleaning. The ink consumed in the cleaning process needs to be collected to prevent ink from leaking in the printer. The collection area is called the spittoon, and in Hewlett-Packard printers this is an open plastic tray underneath the cleaning, wiping station. In Epson printers, there is typically a large absorption pad in a pan underneath the paper feed platen. For printers several years old, it is common for the dried ink in the spittoon to form a pile that can stack up and touch the printheads, jamming the printer. Some larger professional printers using Solvent Inks may employ a replaceable plastic receptacle to contain waste ink and solvent which must be emptied or replaced when full. There is a second type of ink drying that most printers are unable to prevent. For ink to spray from the cartridge, air must enter to displace the removed ink. The air enters via an extremely long, thin labyrinth tube, up to 10 centimeters long, wrapping back and forth across the ink tank. The channel is long and narrow to reduce moisture evaporation through the vent tube. But some evaporation still occurs and eventually the ink cartridge dries up from the inside out. To combat this problem, which is especially acute with professional fast-drying solvent inks, many wide-format printer cartridge designs contain the ink in an airtight, collapsible bag that requires no vent. The bag merely shrinks until the cartridge is empty. The frequent cleaning conducted by some printers can consume quite a bit of ink and has a great impact on cost per page determinations. Clogged nozzles can be detected by printing a standard test pattern on the page. Some software workaround methods are known for rerouting printing information from a clogged nozzle to a working nozzle. Advantages. Compared to earlier consumer-oriented color printers, inkjets have a number of advantages. They are quieter in operation than impact dot matrix or daisy wheel printers. They can print finer, smoother details through higher printhead resolution, and many consumer inkjets with photographic quality printing are widely available. In comparison to more expensive technologies like thermal wax, dye sublimation, and laser printing, inkjets have the advantage of practically no warm-up time, and lower cost per page. However, low-cost laser printers can have lower per-page costs, at least for black and white printing, and possibly for color. For some inkjet printers, monochrome ink sets are available either from the printer manufacturer or from third-party suppliers. These allow the inkjet printer to compete with the silver-based photographic papers traditionally used in black and white photography, and provide the same range of tones, neutral, warm, or cold. When switching between full-color and monochrome ink sets, it is necessary to flush out the old ink from the printhead with a cleaning cartridge. Special software or at least a modified device driver are usually required to deal with the different color mapping. Some types of inkjet printers are capable of very high-speed printing. One commercial high-speed inkjet printer can print on 30-inch wide web at 200 meters per minute.